Hey guys, today we're going to talk about standard form of a line. So standard form is ax plus by equals c. Okay, a, b, and c cannot be fractions or decimals. And they are relatively prime to one another, which means that they don't have to be all prime numbers, but they are prime to each other, which means they shouldn't have any common factors. Our a value also needs to be positive. Okay, so let's look at example 1. If we wanted to rewrite these equations in standard form, I can look at example 1 and see that it's in slope-intercept form. So that means that my y is equal to this expression. So I need to get my x's and y's on the same side and on the left. So I'm going to go ahead and bring my x's to the left-hand side by using inverse operations, just like we would if we were solving a literal equation. Okay, since this is a negative value, I need to add it. So on the left-hand side, I'm left with 3x, or 3/7 x plus y equals 5. Okay, so our x's and y's are on the same side, but we had said we cannot have any fractions. So in order to get rid of fractions, we are going to multiply the entire equation by the least common multiple, which in this case happens to be a 7. So when we multiply by 7, our 7's are going to cancel for our x's, and you're left with 3x plus 7y equals 35. So remember to multiply to each term in the equation. Okay, let's just do a double check. X's and y's are on the same side. No fractions or decimals. My a value is positive, and I do not have any common factors between 3, 7, and 35. Okay, let's look at example 2. Example 2 is in point-slope form. Okay, so when I have an equation in point-slope, the first thing I'm going to do is distribute. Okay, so I'm going to distribute the 4. And now I need to get my x's and y's on the left-hand side, constants on the right. So I could do this in 2 steps, or I could show you how you can do it in 1. So my x's, I'm going to move to the left. Okay, because this is positive, I need to subtract, so that's going to cancel on the right-hand side. I have a negative 4x. I'm going to write that out front. There's my positive y. And I know that 3 is a constant, so I'm going to need to move it to the right. So since it's a positive 3, I would subtract it. Negative 4 minus 3 is negative 7. And if you wanted to write that down in 2 steps, you could. Okay, so x's and y's are on the same side. They're equal to a constant, no fractions or decimals, but my a value needs to be positive. And in this case, my a value is negative. So in order to change that, I can do that pretty quickly by dividing the entire equation or multiplying the entire equation by a negative 1. This essentially will just flip my signs. So my equation in standard form is 4x minus y equals 7. Now, if you wanted to check your work using your Desmos calculator, you can do that by typing your original equation. Okay, I typed the first one in the point slope equation in my equation 1, and then my standard form in equation 2. And what I notice is I only see one line. I can kind of scroll above and below. Okay, they're the same line, which means I did it correctly. We're not changing the value of any of these numbers, we're just changing form, so you should be graphing the same line. Okay, go ahead and do 2 more equations real quick. Looking at number 3, okay, again I need to get my x's and y's on the same side, constants on the right. Okay, when I do that, okay, I'm moving my 3 to the right-hand side by adding. This is in slope-intercept form. I need to get my x's and y's together, so I'm going to subtract 1/4 x from both sides. Again, I do that because this is positive. I'm always using inverse operations. Okay, so in this case, right away I'm looking, my x's and y's are on the same side, but I have a fraction, and I notice that my a value is negative. So in order to kind of eliminate both those issues at one time, I'm going to multiply by a negative, so this will make this be positive, and I'm going to multiply by the least common multiple in my denominator to get rid of the fraction. Okay, so a negative times a negative is a positive. My 4's are going to cancel, which leaves me with x. Negative 4 times y is negative 4y. Negative 4 times 3 is negative 12. Okay, so x's and y's on the same side, no fractions or decimals, a value is positive. All right, let's go ahead and let's do number 4. Okay, so again, this is in point slope. So I'm going to distribute. Okay, 3 does not go into 4. So when I multiply fractions, I get 8/3. Okay, right away I'm seeing 2 different fractions. Instinctually, I want to subtract 2 from both sides, but I don't want to do that right away. Okay, because I have a fraction. So I'm going to make my life easier and eliminate my fractions right now by multiplying the entire equation by 3. That leaves me with 3y plus 6. My 3's cancel here. My 3's will cancel here as well. Okay, so in order to get x's and y's on the same side, I'm going to do this in one step here. I'm going to be subtracting 2x from both sides. There's my 3y. I know I need to get my constants on the right-hand side. So I'll be subtracting 6. This canceled. 8 minus 6 is 2. I just have one last step because my a value is negative, so I'm going to divide the entire equation by negative 1. And again, I could go back and double check all of these using my Desmos calculator. Okay, there's just one other quick thing I want to show you. So when I talked about equations being relatively prime, this would be an example where that's not the case. Okay, 3, 6, and 12 all have a factor of 3 in common. So even though, yes, this in some math textbooks would be acceptable for standard form, we want the best answer. So since they all have a 3 in common, I'm going to divide every single term by that common factor. This would be the best way to write this equation. So that would be the answer that I'm looking for.